Okay, I'm going to try to explain this on a little piece of paper here. Your problem is to write the square root of negative 75 in terms of I. Simplify your answer. The thing you have to remember is I actually represents the square root of negative 1, and that's known as the imaginary number. Now, before students learned about I, when they would run across a problem like this, the square root of negative 4, if you put that in your calculator, if you put negative 4 in your calculator and hit your square root button, you're going to get some kind of an error message because there is no answer to that. So before you learn about imaginary numbers, you would just say the answer is undefined. And the reason it's undefined is if you look at a positive number, like 4, positive 4, the square root of positive 4 actually has two answers, 2, but also negative 2. That's because if you take a positive 2 and square it, you get positive 4. But if you take negative 2 and square it, negative 2 times negative 2 is also positive 4. So when you take the square root of a positive number, you actually get two answers, 2 and negative 2, because if you square those numbers, it takes you back to the 4. There is no number that you can square that'll ever give you a negative 4. Because if I square positive 2, I get positive 4. If I square negative 2, I get positive 4. There is no number that you can square that'll give you a negative 4. So that's why we just called it undefined. Well, enter imaginary numbers. Somebody invented this. And actually it's used a lot in electronics. I'm not really sure how. I just know they use it a lot. But I represents the square root of negative 1. So at this point, once you learn about that, if somebody says, hey, what's the square root of negative 4? I would say that the square root of negative 4 is actually 2i. Because you're going to break it down. You're going to break down the square root of negative 4. You actually break it down to be the square root of 4 times the square root of negative 1. The square root of 4 is 2. The square root of negative 1 is I. And there's your 2i. Now, the 4 is actually what they call a perfect square. And knowing your perfect squares can actually help you in this process. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. You see where I'm going with this? 8 squared is 64. 9 squared is 81. 10 squared is 100. I could keep going, but it helps to know your perfect squares for problems like this. Now, 75 is not a perfect square. 75 actually falls between 64 and 81. The square root of 64 is 8. The square root of 81 is 9. All the numbers in between 64 and 81, like 65, 66, 67, 68, blah, 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 blah. If you put those numbers in a calculator and hit the square root button, you're going to get an 8 point something or other. Well, they're not allowing you to use a calculator here. They want you to simplify the radical. So I have to look at 75 and ask myself, are there any factors of 75 that are perfect squares? Well, one you just kind of disregard in this process because the square root of 1 is 1, so he's kind of a waste of time. But is 4 a factor of 75? Meaning, does 4 divide into 75 evenly? No. Does 9? No. Does 16? No. Does 25? Yes. So I'm going to start by breaking this down to be, I like to make it look like a little factor tree. 75 is actually 25 times 3. But I'm going to put the negative sign with the 25. So I'm going to say the square root of negative 25 times the square root of 3. The square root of 25 is 5. I hope this is recording okay. Well, the square root of 25 is 5. Because it's a negative 25, that's going to be a 5i. 3 is not a perfect square, and I can't pull any factors out of 3 because it's a prime number. So I'm just going to leave that as 3, square root of 3. So my answer is 5i times the square root of 3. Let's say they had asked you to do, let's do another one here. The square root of, whoops, it's blurry. The square root of a negative 12. I'm looking for a perfect square factor of 12. That would be 4. 4 actually goes into 12. 3, there's that 3 again. So I'm going to break this down to be the square root of 4 times the square root of 3. Put the negative sign with the perfect square. And I always put it first because I'm actually going to be able to completely take the square root of this. So this little square root symbol right here will go away. This square root symbol will not. I can't take the square root of 3. He's just going to stay as the square root of 3. And then the square root of negative 4 is 2i. So my answer is, whoops, 2i square roots of 3. I hope that explains that for you.